In the last video, we were seeing about what were the different components of a nucleic acid. We saw that the nucleic acid is basically made up of a nitrogenous base, a sugar molecule, followed by that a phosphate linkage, or what you call as the phosphoric acid. We also saw how the different sugar bases, the sugar molecules, are actually designed, chemically structured. We were seeing about those aspects of that in the previous video. In this video, we'll be seeing about how the nitrogenous bases, that is apart from the phosphate, which we'll be seeing in the next video, and the sugar, which we saw in the previous video. Apart from these two, what are the nitrogenous bases, what are the components of the nitrogenous bases, and how exactly these are structurally designed so that they form a part of the nucleic acid. We'll be seeing about it one by one. Basically, the nitrogenous bases are divided into two categories. The first one is called as a purine, and the second one is called as a pyrimidine. It is called as a purine and a pyrimidine. Now we'll take about each one of them individually and we'll analyze them. The first one is called as the purine. If you take purine, there are two molecules which come under this category of purine. The first one is called as an adenine or an adenine, however you can pronounce it. It's as per your comfortability. And the second one is guanine. Adenine is represented by capital letter A and guanine is represented by a capital letter G. Usually, as per the words, the first letter of the word is taken to represent that particular letter. You'll be finding the same thing in pyrimidine as well. So cytosine is represented by C, thymine is represented by T, uracil is represented by U. So coming back to purine, adenine is represented by A and guanine is represented by G. So these are the two basic purines that is found as a nitrogenous base. Now these purines are basically dicyclic compounds. What do I mean by dicyclic compounds? Now let me draw a structure. You would have seen the structure when you're grade 10 itself while studying about carbon and its compounds. And now too in chemistry you would have come across this kind of a structure. So there are different kinds of structures in chemistry for different compounds. The first one is called as a normal skeletal structure, which will be branched like this. C, and then you'll be having some bonds. It's called a skeletal structure. And when you try to put them in the form of a ring, where it is a closed circle, encircle, this is called as a cyclic structure. Now these purines are basically cyclic structures. They are not just cyclic, they are dicyclic, which means if I'm going to add one more cyclic compound to it, it becomes a dicyclic compound. So these kinds of purines are basically dicyclic structures. Coming to the next one, these are the speciality of the purines and pyrimidines is they are nitrogenous bases, as the name suggests. So whenever I'm going to draw any structure like this, it is by default understood that all these points of joints are going to basically contain carbon. So this is by default understood. When I draw a ring structure at the places of the joint, what is going to be present? It is nothing but carbon. So apart from the carbon, as the name suggests, they are also going to have some nitrogen within them. It is only the number of nitrogen and the bond between the sugar and the nitrogenous base that completely separates them into a purine or a pyrimidine. We'll be getting into that. So they basically contain 4 nitrogen atoms apart from the carbon. And where are these actually present? They are present in the first position, third position, 7th position, and the 9th position. So basically in all the odd positions, the nitrogen is being seated in this dicyclic structure of purine, except the 5th position. Why not in 5th position? You'll be getting to know about it when we read about the further biochemistry of the same. Now, what happens is, when I'm telling that 4 nitrogen atoms are present in these 4 positions, it is very important to know that this nitrogen plays a very crucial role in stabilizing this complex cell structure. So we'll come to that a little later. Fine. Now, how does the bond formation take place? We always know that the purines and the pyrimidines bond with each other. We also know the purines and the pyrimidines bond along with the sugar molecule. How does this bonding take place? We'll see. The bond always takes place with the first carbon of the pentose sugar, which we'll be seeing the structure of the phosphate we'll be seeing. But the pentose sugar, in the previous video, we have seen what is a pentose sugar and what is a deoxyribose sugar, what is a ribose sugar. We have been seeing about all those things. So a pentose sugar, the first carbon of the pentose sugar, and along with that the ninth nitrogen of the purine, that is this ninth nitrogen. So what happens is, one of the nitrogen is actually present in the ninth position. So the bonding will actually take place between the ninth position nitrogen and the first carbon of the pentose sugar. So to give you a quick recap of how this naming is done, it is always done in anti-clockwise direction. So it will be named like 1, 2, 3, 4, 5, 6. It goes like this. So if you can remind that one, then this will be easy for you to catch up. So the bonding for a purine always takes place between the first carbon of the pentose sugar with the ninth nitrogen of the purine. Okay. Now coming to the pyrimidine. The pyrimidine consists of three main molecules. The first one is called as a cytosine, followed by thymine, and then a uracil, all represented by C, T, and U respectively. Now these are monocyclic compounds. They are not dicyclic, they are monocyclic, which means they'll just have structures like this. And these two have the significance of nitrogen atoms in their complex, but not as much as you find in purine. They'll just be having two nitrogen atoms, and the two nitrogen atoms will be found in the first and the third position, which means if I'm going to start naming from here, 1, 2, and 3, nitrogen would be present here and then here. So the second carbon, the nitrogen is basically not present. And how does the bonding take place? The bonding always takes place between the first carbon of the pentose sugar. Here also it is the first carbon of the pentose sugar and the third nitrogen of the pyrimidine. So it's very simple here. Even if you don't know what is the nature of the pyrimidine, just by knowing which nitrogen has actually bonded with the sugar molecule, you can tell whether it's a purine base or a pyrimidine base. Just see here, in both the conditions, first carbon of pentose sugar is going to get bonded. But it is only the decisive action of which nitrogen is going to be bonded, that whether it is going to be a pyrimidine or whether it is going to be a purine. So if the ninth nitrogen is going to get attached, then you can very well tell it's a purine, and only if a third nitrogen is going to get attached, it is called as a pyrimidine. So to keep it very simple, we'll make a quick recapitulation of everything. The nitrogenous bases are basically divided into two categories, purines and pyrimidines. Purines are of two types, adenine, guanine, and they are dicyclic compounds. They contain 4 nitrogen atoms at the first, third, 7th, and the 9th position of the carbon, and the bond usually takes place between the first carbon of the pentose sugar along with the 9th nitrogen of the purine. Coming to pyrimidine, they are of 3 categories, 3 molecules basically, cytosine, thymine, and uracil. They are monocyclic. They contain only 2 nitrogen atoms at the first and the third position. The bonding always takes place with the first carbon of the pentose, which is going to be common for purine and pyrimidine, and the third nitrogen of the pyrimidine. So this is what the nitrogen base, which occupies the bridging role in this nucleic acid. So in the next video, we'll be seeing what exactly is the phosphate and the structure of the phosphoric acid.